back. We are on day 2 of 5.5 function operations, and today we're going to be talking about composite functions, a function within a function. Okay, so composite function is the result of applying the rule for one function f to the rule of another function g, or even backwards, function g to function f. This is the notation you'll see, this f and then kind of an open circle of g of x, which also can be written like this, f of g of x. So kind of the function of g is substituted in for f. So it's written f of g of x, okay? The operation, open circle here, that forms the composite function is called the composition of functions. So the domain of f of g of x is a set of all real numbers of x of the domain of g, such that g of x, so the domains are kind of the same, kind of the composition of them, okay? So this is kind of an example of composite functions. It's created when one function is substituted into another one. Example is we have this red function, f of x is 3x plus 2, and g of x equals x plus 5. So if we're going to do f of g of x, that means that g of x is going to go inside of f of x. That means we're going to take this blue function part, g of x, we're going to substitute it wherever we find an x inside of g of x. So it's going to become 3 times, and instead of x, we're going to put that x plus 5 and then plus 2. So you can kind of see this 3x plus 2 right here, 3x plus 2, but instead of x, we're substituting in the entire function, x plus 5. Then of course we simplify, 3x plus 15 plus 2, that becomes 3x plus 17. If we do the composite function g of f of x, that means that f of x will be substituted in for g of x. That means we're going to take this g of x function, x plus 5, so you can kind of see this x plus 5, but instead of x, we're going to substitute this 3x plus 2 in for x. So x plus 5, and then of course we simplify 3x plus 7, okay? So it's kind of a little weird concept to kind of grasp, but once you understand it, it's not too bad. You're just taking a whole function, a whole expression, and substituting it in for x on the other function, okay? So if we let f of x equal x squared and g of x equals x plus 1, investigate what happens when you apply the rule for g and then the rule for f for a number. So the number is actually quite easy. All you're going to do is say, okay, what's g of 3? Okay, so g of 3 first is equal to, and that's my function x plus 1. So we're going to go 3 plus 1. So that's going to be 4, right? So g of 3 equals 4. Then we're going to take that 4 and we're going to plug it into our f of x. So then we're going to take f of 4. Now we're going to take this, right, and evaluate it in the function of f. So f of 4 equals, and it's going to be x squared, right? X squared. So we're going to substitute that 4 we got from the g function and put it in there. And so this becomes 16. So f of 4 becomes 16. So f of g of 3 equals 16. Because we evaluated g first, we took that result, plugged it in for f, and we got 16. Okay? Well, now what happens if we just write the rule for g of f of x? We don't plug in a number, we just want x, right? So we're going to actually just take now where f of x, f of g of x equals x squared, and now we're going to take this entire x plus 1, right? And we're going to substitute it in for this x. So that's going to become x squared, right? That's what the function is, but we're going to plug in x plus 1 right there. So that's x squared, okay? So that becomes, if we multiply that out, sorry, blue, it's not changing to blue for me. That's going to become x squared plus 2x plus 1 if we multiply that out. That's my f of g of x, okay? All right, so you guys can maybe try this. Maybe pause the video and see if you can do this f of g of x. So we're plugging in g of x into f of x, okay? So we have our f of x right here. We have our g of x right here. We're going to find our f of g of x. So we're going to substitute, right, this guy right into this x right here, okay? So we have f of g of x equals 2x. We have 2x minus 1, so we have 2, and where we have the x there, we're going to put in 3x. Whoops, I need my orange. 3x. Okay, need my blue back. 3, oh my goodness, I can't get my blue. There we go. 3x and then minus 1. So you can see we have this 2x minus 1, which is my f of x, but I'm plugging in my 3 of x, or my 3x into that x for my f of x. Okay, so this becomes now 6x minus 1, and that is my f of g of x. Okay, we're plugging in that whole function g of x in for x for the f of x. All right. Okay, so now we're just going to practice writing rules. So what's the rule for composition of f of g of x? When you see it written like this just basically means the same thing, f of g of x. Whoops, f of g of x. Okay, so that's the same thing. So we're going to take g and plug it into x over here. Okay, so f of g of x is going to equal the square root of, and I'm going to go ahead and plug in my 2x minus 5. And then my plus 7, okay, that's going to equal square root of 2x plus 2. And that's my f of g of x. And that's it, okay? So now identify the rules for both f of g of x and g of f of x, okay? So you might want to pause the video and try this out and see how you do. All right, so I have f of g of x here. That means we're going to plug g in for x, so we're going to have x plus 1 cubed. Okay, and I'm just going to leave that there. I'm not going to make you multiply that out. Okay, you might have to do that for an Excel, but that's good enough there. And then if we have g of f of x, this time we're going to plug in the f of x into g of x, so that's going to be x cubed plus 1. Okay, and there you go. All right. Identify these rules. So we have f of g of x. So we're plugging in g over here. So it's going to be equal to x minus 5 squared plus 1. Let's go ahead and simplify that. So x squared minus 10x plus 25, and then plus 1. So it will be x squared minus 10x plus 26. And that's my f of g of x. Okay. What about g of f of x? That's going to be equal to, you're going to plug in x squared over here, so that will be just x squared plus 1 for x, and then minus 5. So that's going to be simplified to just x squared minus 4, and that will be my g of f of x. Okay? All right, so now we're going to kind of look at, we have this kind of coupons. We can get $5 off our next purchase. And we also have a coupon that's 10% off our next purchase also, okay? So we're gonna write a function for which one we apply first. So if f of x is, we're gonna take $5 off the next purchase. So if x is my purchase, minus 5, that's my price, okay? Or we have this 10% off, so we take our price, minus 10% off, ends up being 1 minus 0.1, which is 90%, right? 0.9 of our price. So that's my g of x, is that 0.9 right here, okay? So g of x is 0.9, f of x is x minus 5, okay? So right here, this is what we have. And so first, the 10% off and then the $5 off, that's going to be my g first, which is my 10% off, then my $5 off. That's that one. So that's going to be f of g of x. So this is inside one is always the one that goes first, right? So my f of g of x, oops, let me get this here, f of g of x. So this inside one is always the one that goes first, right? So we're going to plug in g, this 0.9 up in here. So it's going to be 0.9 x minus 5, okay? And that's my 90% first, then my $5 off. Well, what if I flip it around? What if I want the $5 off first and then take the 10% off? Okay, that's my rule for g of f of x, okay? And so that rule is going to be taking my $5 off first, then my 10%. So I'm going to plug that in there. So it's going to be x minus 5 for my x. Oh, sorry, with the wrong one here. We got to take our 0.90, 0.9, and then substitute that x minus 5, right? So we're taking 90% of our x minus 5. So $5 off our price first, and then taking 90% of it. Okay, so that's a rule for that. And if we simplify that, of course, that would be 0.9 x minus 0.9 times 5 times times 5, whatever that is, okay, times 45. So 0.9x minus 4.5, okay? And that's my g of f of x, okay? So now we look at one here. It says, as a member of the Game Shop Award, you get 20% off your discount on purchases. So we're going to assign that g of x is going to equal 20% off your purchases. So my purchase is x. We're going to subtract 20%, 0.20 times x. That's going to leave me with 0.8x. Okay, that's my g of x right here. All sales are subject to a 6% sales tax. So that's going to be my f of x. And that's going to be my price plus my 6%, so 0.06x. So that total is going to be 1.06x. That's my sales tax. Okay. Write functions to model the discount and the sales tax. That's what we just did here, the discount and my sales tax. Then identify the rule for the composition function that calculates the final price you would pay at Game Shop. Okay. So basically, we would want to write f of x, f of g. My goodness, let me erase that really quick. We would want to write where we have the sales price first and then apply the tax, because you don't apply the tax first and then take the sales price, right? So we want to have this one first, so it's going to be f of g of x, because remember the inside one occurs first, then the outside one, okay? So we don't want to have that one, f of g of x, because we want to apply g of x first. So that's going to be 1.06, and then my x will become my g of x, so 0.8x. And there you go. And if we wanted to simplify that, we could multiply 1.06 times 8, which I'm not going to do that at this point here, okay? Okay, and so that's it for composition of functions, and actually all of our addition, subtraction, multiplication, and division as well, kind of a summary. And then you guys will have an Excel in Google Classroom. Be sure to attach all your work honestly, and then I will see you in class. Thank you. Bye-bye.